Okay, so now we're going to talk about the historical reasons for engineering curriculum. Technical focus like engineering science, basically engineering science. We're going to talk about the historical reasons. So to put this in context, we talked about future work skills that are required for engineers. We talked about the current image of the engineering profession and the past image. We talked about the fact that recruiting engineers as young graduates to come into engineering has become very difficult because of the public image issues and a lack of understanding of what's required from a future point of view. Now we're going to talk about the historical reasons for a technical focus. Okay, so we've said that one of the things throughout the 19th and 20th century, and even into the 21st century, is the poor image of engineering. Where in the 19th century, early 1800s, mid-1800s, engineers were perceived as heroes in the UK, for example, with railroads and building all the great infrastructures, to where in the 20th century the role of engineering image has declined. And we've said also that it starts in schools. We've also said that the status, engineers are absolutely obsessed with status. Not just in the UK or USA, Canada also, engineers are constantly complaining about their role and status in society versus lawyers or doctors or accountants, etc. Now, I can say as a person who has lived and worked in all those countries, Canada engineers are probably the best off the way the profession is structured, but it still has a way to go. But probably the image of the engineer in schools in Canada is very different than that in a British school. Where in Canada, there are various reasons, and we'll explore them, the concept of the iron ring, which was from the 1920s, how that has bonded a brotherhood among engineers. The licensing, we're one of the courses, I think module 10, will talk about licensing of engineers, how licensing with an act in Parliament and how that underwrites the engineering role in society and provides them with authority and status unlike their UK counterparts. So what had happened from the middle 19th century all the way through into the 20th century, the engineering profession and education, in order to get status, lumped themselves with science, used science as a way to enhance status and become a university subject. The fact is that engineering science was very little of that theory has been used by engineers in real practice. There was an old story that the French engineers will be talking about how the French engineers professionalized around the military in the late 1700s during the Napoleonic era and created the famous great engineering school that exists today, the École Polytechnique in Paris, and how they relied heavily on mathematics and engineering science, and that when they designed their bridges fell, and they could tell you why the bridge fell through calculations, where the British engineers designed bridges and they stayed, they very rarely ever failed, but they couldn't tell you why they didn't fail, they couldn't scientifically tell you, they just knew through rules of thumb. British, for example, right up until the 1980s, right up till the 70s, trained all their engineers through apprenticeship. Only 2 to 3% of engineers in the UK, up until the 70s, would have an engineering degree, a university degree. So most of the engineers there were trained through the technical apprenticeship, 5-6 year apprenticeship, and then technical school, with qualifications that wouldn't have anywhere near the same theoretical knowledge of an engineering degree based on all the sciences, but had enough knowledge to be able to design aircraft and to be able to design power stations and stuff without having the advanced mathematics and the advanced science that we have in our current engineering programs. So science grew, engineering science education grew in a way to make engineering seem more academic and in a way to acquire status. The civil and the mechanical engineers were the first to adopt the sciences. And the whole idea, of course, was to separate their image and role from the trades, and technicians. So some of the drivers of the intense scientific education we get in engineering degrees today, a lot of it, its roots was based on enhanced status. And we're going to explore that. We're going to do some research to prove that point and to see how we may have drifted into overly scientific focus rather than on the social and the technology focus. So when you move this way, you're dealing more with the social, and when you do this way, you're dealing with theory. This is practical and application. This is theory and discovery. So we're finding that engineering degrees have tended to move this way, to the detriment of this. And so because engineers are not adept at these kinds of skill sets and thinking capabilities, other professions take it over. Lawyers, economists, social scientists, etc. As I mentioned before, in the UK, which was the greatest industrial nation in the world in the 18th and 19th century, before it was superseded by the United States and Germany, most engineering was done with trial and error. Tried things. The massive shift to a scientific education, to engineering science, leaves little room for liberal arts, for other studies. So it leaves little room for a broader education. Now, there's been lots of studies in the United States and in the Royal Academy of Engineering in the UK. You'll get to read these in the course where they've recognized this and they're calling for a transformation of the whole engineering education and practical experience system. Most design decisions are actually not based on pure scientific reasoning. Many of them are based on feeling, tacit knowledge, knowing that something will work because of years of experience, years of apprenticeship, or generations that have passed knowledge down. They haven't had the time to sit and do mathematical calculations to know that if you put a machine together in certain ways, that it will work. I'm not saying that science is not required. That's silly. Of course it's required as we move into a more complex technological age. But when we move and our education system becomes focused mainly on this, to the detriment of the application of it, it's a big problem. Now the other thing too is vocational education. So engineering in the UK, for example, and in the US, in the early years was defined as a vocational education, non-academic. It's ridiculous. How could thermodynamics and fluid mechanics or mechanics of machines, the most advanced mathematics you can get, not be considered academic? But that's the public image. That's how governments defined engineering as a vocation. Well, it is a vocation, But medicine is a vocation, law is a vocation, but terminology, we're going to explore how terminology shapes public perception and shapes curriculum that's developed and shapes how engineers themselves are defined. So these definitions have different meanings in different countries. And the fact is that vocational education was looked down upon. In the UK, in 2012-13, and moving into 14-15, there is a huge thrust by the government to enhance the old-fashioned apprenticeships, to bring apprenticeships back. They talk about it like it's something new, but the apprenticeship system that they had in the 1940s, 50s, 60s, and 70s, and into the 80s, and some companies today still have them, was among the best educational systems in any country in the world to train engineers. And pretty much they were destroyed in the 1980s, 1990s, and the government now realizes that apprenticeships is the way forward with respect to training the future workforce. Whether they're graduate, where they parallel with universities to become graduate engineers or technicians or technologists. All you have to do is go on the internet, put in UK apprenticeships, and you'll get thousands of hits and the big changes. The philosophy of many universities giving this engineering science education, when you want to get hands-on, meaning actually design practice, get it in industry. Now, there are universities who do co-op systems. You spend 2 or 3 months or you work simultaneously with an employer. The old British apprenticeship system used to, for the 5 years, used to be industry. You had an industrial employer and college. So you were at the tech college. And so you would be here 1 to 2 days per week over the 50 weeks and in your employer. So you were getting theoretical training and using it embedded together. And at the other end, from year 1 to year 5, fully qualified. Because the practice and the theory were embedded hand in hand. Now they want to try to bring this back. When universities are heavily scientific oriented, there's very little of this happening. There's very truly little of embedded learning, embedded practice and theory simultaneously. Now, again, historical reasons for engineering's technical focus. Science, status, grew immensely after the Second World War, World War II, because it was science was given the credit for the atomic bomb. Now, the atomic bomb, we'll discuss later, the atomic bomb itself was a political artifact, not just an engineered artifact. It was for political reasons, where the United States basically said to Russia, back off, look what we have. But science gained huge status in the space shuttle program, and so therefore, after World War II, science became even more embedded in the engineering educational curriculum, to the point where today many engineers going out are not thinking like practical engineers.